Let's factor the denominator here. Let me get attention. X minus 2. X squared plus 2x plus 4. That's the difference of two cubes. Same, opposite, always plus the slope, right? So we break this up into a over x minus 2, and then plus bx plus c over x squared plus 2x plus 4. Now we need to get common denominator. Let's multiply this one by x squared plus 2x plus 4 on the top and the bottom, and this one by x minus 2. When we do that, we get 10x squared plus 12x plus 20 is equal to ax squared plus 2ax plus 4a. All right, that's running the a through. Now I need to FOIL. So plus bx squared minus 2bx plus cx minus 2c. Yikes, a mile long. We get a plus b is equal to 10. There's a plus b. I need the x's. 2a minus 2b plus c equals 12. 2a minus 2b plus c. Got it. And then 4a minus 2c equals 20. Well, I think it'd be easier to do this on the calculator than it would by hand. So let's do that. Let's go into matrix. We're going to edit a. It's a 3 by 4. Now we have 1, 1, 0, 10. So the first one would be 1 for the A, 1 for the B. There's no C. Remember, there's A, B's, and C's. So 0 for the C, and then 10. And then 2, negative 2, 1, and then 12. And 4, 0, negative 2, 20. We're going to quit out of there, go back into matrix, do the math, and it's RREF, reduced row echelon form. We want matrix A, and our A, B, and C is 7, 3, and 4. We end up with 7 over x minus 2 plus 3x plus 4 over x squared plus 2x plus 4. So sometimes it's easier to do it by hand. Well, I think that's the next one I'm going to do. Sometimes easier to do the calculator. You have to decide. Find the partial fraction decomposition. We want this equal. First of all, I don't have to divide because the bottom power would be bigger if I multiplied it all out. So we have ax squared plus b over x squared plus 1 plus cx plus d over x squared plus 1 squared. We need common denominator, which means we're going to multiply this by x squared plus 1, and I don't have to multiply anything times the other one. 3x to the third plus 5x minus 1 is equal to ax to the third plus ax plus bx squared plus b. Is that right? Ax to the third, outside is ax, bx squared, last is b. I think I got it. Plus cx plus d. This one I don't think we need calculator for. A is 3. That's the next to the third. The x squared, b is 0. The only x squared we have is b, and there's no x squared on the left side. A plus c is going to be equal to 5, and b plus d is equal to negative 1. Well, I know what a is. 3 plus c is 5, so c is 2. And we know what b is. B happens to be 0, so d must be negative 1. It'd be much harder to put this into the calculator, or at least take more time. Don't need the calculator for this one. 3x plus 0 over x squared plus 1 plus 2x minus 1 over x squared plus 1 squared. Use inverses to solve. Let's put this as a matrix equation. 2, negative 1, 1, 3 times xy is equal to 3, negative 1. Now, if we call this matrix A and we call that B, then we want to multiply both sides times A inverse. And you have to have A inverse first, or else you wouldn't be able to multiply, the dimensions wouldn't match up. We have 6 minus negative 1, that is 7. So we have 1 over 7 times 3, 2, 1, negative 1. So you switch 2 and 3 and you make the others opposite. Looks like we switched the others, but we didn't. We just made them opposite. And that's times 3, negative 1. I have 1/7 times 9 minus 1, 8. And then negative 3 minus 2 is negative 5. So the ordered pair is 8/7, negative 5/7. So it didn't come out nice. That's okay. Doesn't always have to. What's that over there? Find the determinant of A and find AB. I'm going to erase this because I infringed on that little area, that airspace. Find the determinant of A. So we have to repeat column 1 and 2. 1, 3, negative 1, and then 2, 2, 4. 4. This is plus now. Plus 2, plus 36. And then we have to minus. So minus 12, minus negative 4, that's plus 4, and minus negative 6, that's plus 6. So 6, I got 42 minus 12, that's going to be 30, plus another 10, 40. Well, now I kind of made a mess because I'm asked to multiply these two together. So I'll erase that so I can see the numbers. A 3 by 3 times a 3 by 2. So we're going to end up with a 3 by 2. 3 rows, 2 columns. And we're going to go across and down. We got 1 plus 0 plus 6. 3 minus 2 minus 12. 3 plus 0 minus 2. And 9 minus 2 plus 4. And then negative 1 plus 0 plus 4. And negative 3 minus 4 minus 8. So here's the final answer. We got 7, negative 11, 1, 11, I think, right? 3 and negative 15. I hope I added correctly. I did that kind of fast. Just be careful on the test. Make sure you don't make little silly mistakes and add wrong and multiply wrong, but everybody does that. Hopefully you won't. All right, how about graphing some inequalities? The signs tell you above or below when they're in slope-intercept form. So imagine getting all of these into slope-intercept form. You would never have to divide by a negative, so the signs wouldn't change. That's good news. How about x and y intercepts? 6 and 6. 6, 6. We don't have equal to, so we're going to make that dotted. So there's the red. The green has an x-intercept of 2 and a y of 8. X-intercept of 2, a y-intercept of 8. I believe that's a solid one. There's the green. And let's make the last one blue. The x would be 4, the y, no, the x would be 7, the y would be 4. X is 7, y is 4. and this one would be dotted also. There's the blue. Well, now we want under the red. We would not change the signs if we put this into slope-intercept form. None of them would change signs. Above the green. So now it could be in the triangle. It usually is in the triangle, by the way. But now below the blue line. So below the blue, it is now not. It's not in the triangle. It's in this little region that goes up against the x-axis. And if we're only doing this in the first quadrant, it would stop there. But if I had the whole coordinate system, that would be an infinite amount of area. Questions on that one? Don't always assume it's in that triangle. It's not always. All right, bye YouTube.